Welcome back. What I want to do is briefly talk about this long machine here, which is called a wash train. And in our case, this is called an SFW 3000, a sequential fiber wash train. 3000 because it has 3 tanks. And I'm currently doing a test run of the whole system, in that I've got the tanks of water filled mostly, and I'm heating up the water in each tank because we start there and we wash the wool in these tanks, with each stage having its own wringer. So the wool goes in there, and not for very long, only 5 or 6 minutes. Then it goes through a wringer, up a conveyor belt, and down into the next tank. So each tank is roughly 145 degrees for wool. Different fibers require different temperatures. Wool is the hottest because of its lanolin content. So it goes through these 3. And the last wringer here the wool gets dumped into a bucket here, and then we'll take it over back there against the wall and put them on screens. That's what these screens are, and hang them up so that the fiber can dry for a while, and then we can carry on with the process after that. So certainly the last 3 weeks plus, my focus has been on getting the plumbing set up for this. In its last location, it had a different configuration, and it was using an oil boiler that kind of sat right about here in relationship to the machine, and I needed to reconfigure it, both for the water supply and to change to a gas-fired boiler. So we got a brand new boiler for this process, and this is what I am currently running and testing and making sure that the settings are more or less the way I want them. And this is a night fire tube boiler from Lochinvar in the States, and I'm really quite impressed with their equipment. This is really well built and reasonably documented. They have lots of documents online that you can get, and all of the documentation in PDF form for pretty much everything that you can think of. So I've been concentrating on getting this installed, getting I had a gas fitter in to put the gas line in, make sure that's all safe, and then the water supply. I used PEX A for this, for the expansion joints, and I absolutely love the stuff. It is dead simple to use and very reliable. So in this case, this line here is to supply the hot water system itself. And there's a main hot water loop, that's the copper. And I use copper here because the boiler has had copper inlet and outlet pipes, and the wash train itself was all copper. So it was just and I was able to use a bunch of the pipe that came with the old boiler when I reconfigured it. So it just made sense to keep the copper in this case. And I'm not as confident with the PEX handling the hot water that I needed. I think there's a type of PEX that you can get for hot water, but in aggregate, it was just more straightforward to use copper. That meant I had to sharpen my soldering skills, so it took me a week to chase down all the leaks that were in the system. Some of them were just either on my part poor soldering technique. The second pass was all that was needed there. Some of it had to do with just joints popping due to the expansion from heat. But in the end, it worked out well. So we got the boiler, and that circulator pump there came with the boiler. And that's pretty much everything that's needed for one of these things. This piece down here is a conditioner. So this is a condensing boiler, and the condensate that comes out is a bit acidic. And so this has agent in there, those little balls that neutralizes the water before it goes into, in our case, the septic system. I don't think I necessarily needed it, but it came with the boiler, so I might as well set it up. It was pretty straightforward. The one little thing that wasn't clear for me, but I was able to solve that with the help of some technical support. The way I understood it was the main loop, the main heat loop. That's the big pipe here. It's 1.25 inch copper. That loop is what the boiler essentially keeps hot all the time. And then each tank has a thermostat with a probe in the tank that comes down to a relay, and this relay is from these relays are from the old boiler. And then this relay triggers an individual circulation pump for each tank. So when this tank needs additional hot water from the hot loop that's in there, there's copper coil that's in there, the thermostat triggers this pump, and it draws hot water from the main loop. All right. So, and then each one of those is each tank has the same thing. Now, these circulator pumps are independent of the boiler, so I don't need to actually hook them up to the boiler. The thermostats don't get hooked straight back to the boiler at all. Now, my understanding, and I am an amateur at this, my understanding was that between the sensors that are built into the system, and there's an inlet sensor and an outlet sensor, temperature sensor, and then there's what's called a system sensor. And that's optional, but you put that in the main heat loop, and then the difference between, this is where I originally had it, the difference in temperature between that and the outlet temperature, which is the hottest, would trigger the demand for heat. That's not how it works, though, because they do sense the temperature in the loop, but you still need a thermostat, a space heating thermostat of some kind, to actually call for heat. That was the kind of little detail that I was missing. But it was a very easy solution to that, was just to, there's three spots in the on the main control panel for thermostats to plug into, and they're called heat loops. So there's heat loop 1, 2, and 3, and I just shorted across the contacts for the first heat loop for continuous call of heat, and then the system will satisfy that call with the sensors in the main loop. Now the tricky part was, in this case, there's a balance that needs to occur between the outlet temperature and the system temperature. And so the boiler heats up, and it's running at 10% right at the moment, as it's getting close to its target temperature that I've set in here. But there's a lag in the heat from the boiler itself, which is the outlet temperature here, and the system sensor here. And if this system sensor is too far down the line in the heat loop, the outlet temperature gets too high and triggers a shutdown, because it triggers above an acceptable temperature, which is 190 degrees. Well, there's a setting where you can go to 210 degrees, but then the system shuts down completely, and I don't want to go there. So what I had to do is I moved the system sensor from here because it was too far away from the outlet temperature, and I moved it closer. So the outlet temperature is in here, right at the boiler, and then that's the outlet pipe that goes down there and that way and comes across here. And for now, I've just taped and insulated the sensor to the outlet pipe right there. That gives me the option of moving it around a little bit if I need to. And so this is close enough so that the temperature drop between this and the outlet temperature isn't too far. And it's working like a charm right now. This is precisely what I want. And now, I have to say, there's absolutely nothing wrong with the boiler itself. This is just an unusual application for this boiler. This is something that you would normally use in a house to heat various zones, either in-floor heating or radiators or whatnot. So I'm running at much higher temperatures generally than what you would find in a typical residential application. But the BTU rating of this one, which is 200,000 BTUs, was what I figured was needed for this system, and it's working out really well. And I base that primarily on the old boiler, which is way over there and is scrapped now, was 185,000 BTU oil boiler. So I figured 200,000 in a gas boiler was going to be more than enough, and it certainly seems to be. And right now, all the tanks are up to temperature. The next big hurdle will be to see what kind of recovery speed we get, because as we're putting wool in, the temperature will drop. We want it to the temperature to come back up reasonably quickly, so within the 5 or 6 minutes that the wool's in there, and then carry on from there. What I'm doing right now is there's a night time setback that you can enter into the programming on the boiler, so that at nighttime for a given number of hours I can keep it at a lower temperature, and then 6 o'clock in the morning it fires back up and brings the tanks back up to working temperature. So that's what I'm here for tonight, to see how that works out. So far though, I'm real pleased with how it's working out. All the leaks have gone, so I'm happy. There'll be plenty more information to follow, and I'll probably give you a little bit more detail on how the setup of the boiler is done. I'll open the front of the boiler to show you where the connections are made. Okay, talk again soon.